Minasan, konnichiwa, Samurai Engineer desu. In this video, let us solve number 11 of page 422 of Feliciano OE. This is our example 163. The question is find the area between curves. So boundary. We will be given boundary, and because the given curve is only one, which is r is equal to 4 quantity 1 plus sine theta, meaning this curve is a loop or it is circular or something. Okay? So by doing the basic plotting of curves, okay, so doing that manually one by one, okay, so I was able to determine that the shape of the curve of this given curve is inverted heart shape. Okay, inverted heart shape. Okay, so now I will draw an infinitesimal strip. Okay, and again draw inside the infinitesimal strip. I will again draw the second infinitesimal strip. So dr. So I also have the outer strip d theta, inner strip dr. Okay. This outer, this is obviously inner. Okay, because why this is inner? Because this is inside the first strip. That's why this is the second strip. Therefore, this is the interior integration. Okay, so what will happen? I will form the integral differential area formula. What is the differential area formula? So length times width. Length is r d theta. Width is dr. So why I am writing it like this? Why not r d theta dr? Because I have said dr is interior, d theta is exterior. So exterior is outside, no? Outside. dr is inner. That's why I wrote it down like this one. No? This is the correct way to write it down. Okay. So integrating both sides, we have the total area, which from negative pi over 2, one rotation up to the negative pi over 2. Okay. So one rotation. But I will do the multiplication because I observed that the left-hand side and right-hand side areas are the same. They are symmetrical with respect to the y-axis. Okay, so times 2. Okay. Exterior integral limits. Exterior meaning theta. What is the exterior? Okay. So that is from negative pi over 2 to positive pi over 2. So from this point to this point, 1/2. That's why I multiply by 2. Okay? Okay? So the next integration would be the interior. Inside. Okay? Interior, that is with respect to r. What is the value of r? From 0 to r. Okay? From 0 to r. What is the value of r? This one. This is the value of r. Okay? So from 0 to r. Okay? And the function is r, dr, d theta. Okay? So we can immediately integrate this one. The interior, we can integrate. So 2 negative pi over 2, pi over 2. Integral of that is r squared over 2. From what? From 0 to r, which is 4 quantity 1 plus sine theta. And then after evaluating that, again integrate the second time. Okay? So let us integrate the first time. So let us do it here. A. You'll notice 2 times 1/2, that is 1. So let us just write pi over 2, pi over 2. Okay. So r squared. Substitute this value. Okay. That is the upper limit to r squared, meaning that will become 16 times quantity 1 plus sine theta squared. Okay. Minus, substitute this to that is 0. So minus 0. And that is only our evaluated function. Okay. Now, let us expand. Put the constant outside of integration, then expand the function. Okay. So 16 negative pi over 2, pi over 2. If you expand this one squared, so that is 1 plus 2 sine theta plus sine squared theta and the theta. Okay? Okay? At any moment, you have a question, please raise it immediately. Okay? So, 16. We can directly integrate 1, 2, the first two terms. So that is what? 1 times d theta. What is the integral of that? Integral of that is theta. Okay, from negative pi over 2 to positive pi over 2. The second term, you can directly integrate. 16 times 2, that is what? 32. Okay, plus 32. What is the integral of sine theta? That is negative cosine theta from negative pi over 2 to pi over 2. The third term, we cannot directly integrate, but we can what? We can use trigonometric identities. Okay? Plus 16, integral of from negative pi over 2 to positive pi over 2. What is sine squared theta? That is equivalent to 1/2 times 1 minus cosine 2 theta. That is the equivalent identity of sine squared theta. This one. Then multiply by d theta. Okay, we can what? Evaluate this one and this one. So, substitute. Pi over 2. Okay? 16 pi over 2. Substitute. Minus, minus. So, minus, minus. It will become positive. Yeah? It will become positive. Actually, okay? Actually, pi over 2 plus pi over 2. That is pi. So, we have what? 16 pi. Okay? And then, plus 32 here. Plus 32. Substitute pi over 2, meaning negative cosine pi over 2. What is cosine pi over 2? Cosine pi over 2 is 0. What is cosine negative pi over 2? Cosine negative pi over 2 is 0. Therefore, all of this is 0. So this will become 32 times 0. All of this 0. Okay? Then plus. Therefore, this is what? 0. Okay? So 16 times 1/2, that is 8. Okay? Integral of d theta, because d theta times 1 is d theta. Integral of d theta, that is theta. From negative pi over 2 to positive pi over 2. Okay? Clear? And then, cosine 2 theta, d theta. What is the integral of that? We have 2. Therefore, that is supposed to be negative 8 times 1/2. Where does this 1/2 came from? This came from these 2. Okay? 2 theta, therefore we have to 1/2. Okay? So negative, negative. What is the integral of negative? Cosine. That is negative sign. So sine 2 theta from what? From negative pi over 2 to positive pi over 2. Okay? Okay. So 8 divide 2 is 4. What can you evaluate from this? Sine 2 theta. 2 theta. Theta is pi over 2. Therefore, 2 times pi over 2, that is pi. Sine of pi is 0. This is negative. The lower limit is negative. So 2 times negative pi over 2, that is negative pi. Sine of negative pi is 0. Okay? So this all will become 0. Okay? So this will become what? So 8 times what? Pi over 2 minus negative pi over 2. And this is what? 4 minus 4 times 0. Okay? So therefore, what is the answer? 16 pi plus 8 pi. Our answer is 24 pi. Okay? Our answer is 24 pi. So, okay? So, you can take a look at our, let us find out if the answer is correct. That is 14.2. 14.2. So, that is 14.2. Number 11. So, number 11. So, the answer is 24 pi. Okay? And also, our number 15 here, 8 pi. So, we are correct. We are correct. Okay? There is no answer for number 10. But we have an answer which is also probably correct, which is 2/3. Okay? So, any question? Any question? So, this is how you should do it. Double integration. Application of double integration, but we are doing it in finding for the area. Okay? Okay. If you don't have question, again, this is Dr. Rippy, preaching engineering for nation building.